Hello everyone, myself Vinay Kumaram. I'm pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry, and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry, and mathematics, then please do subscribe to my channel. So in my previous videos, I had started the 8th chapter of 9th standard mathematics. That I have covered most of the concepts which are there before exercise 8.1. And also in exercise 8.1, I have solved first and second question. You can refer the previous video for that first and second question. So in this particular video, we'll look into the next questions after second question. That is in exercise 8.1. So now we are discussing exercise 8.1. In this exercise 8.1, we'll be looking into the third question. So in third question, they have given a diagram. So let me draw that particular diagram over here. So we have a parallelogram in this particular diagram. So here this point is named as A, B, C, D. So the parallelogram ABCD is given, in which they have drawn a diagonal AC like this, in which they have already mentioned in the question that this particular angle and this particular angle are equal to each other because of this particular line bisecting this angle A. So that means the data which they have given here is DAC angle is equal to this particular CAB angle. So CAB. So now DAC is equal to CAB, that they have already given. So now you have to prove that this particular angle and this particular angle are also equal to each other. So now in order to prove that, we already know this is a parallelogram. So in parallelogram, opposite sides will be parallel to each other. So now we will prove this. So in this third question, we are looking into the first question. So in this first question, you need to prove that this AC also bisects this C. That means this angle and this angle should be equal to each other. That is what we have to prove in this particular first question inside third question. So now, based on the data which they have given here, and they have also mentioned that ABCD is a parallelogram. So that means here, since ABCD is a parallelogram, since ABCD is a parallelogram, DC is parallel to AB. So here DC is parallel to AB and also AD is parallel to BC. So DC is parallel to AB and AD is also parallel to BC in this particular parallelogram. So that is, these two lines are parallel to each other and these two lines are parallel to each other. So now based on this data, you have to prove that this particular angle C is bisected by this line AC. So now, because DC is parallel to AB and AD is parallel to BC, here this particular angle, that is this angle, will be equal to this particular angle because they act as alternating angles, and this particular angle will be equal to this particular angle because here AD is parallel to BC, so they also act as alternating angle. So here CAB angle, that is this particular CAB angle, will be equal to this particular DCA angle. So CAB angle is equal to DCA angle, and here this particular angle, that is DAC, will be equal to ACB. So DAC is equal to ACB angle. So this is because so the first one is because these two lines are parallel, that is DC is parallel to AB. So DC is parallel to AB, and this second one is because here AD, this particular line AD is parallel to BC. So AD is parallel to BC. So these two, because based on these two data, we are getting CAB is equal to DCA and DAC is equal to ACB. And in the data they have given DAC is equal to CAB as well. So that means this particular DAC is also equal to CAB. So DAC is also equal to CAB. So since DAC is equal to CAB and DAC is also equal to ACB, so here we'll call this particular equation as equation 1 and this particular equation as equation 2 and this one as equation 3. So since DAC is equal to CAB, so now I will rewrite the first equation, that is in the place of CAB, I'll write DAC because DAC is equal to CAB, which they have already given. So in the place of CAB, I'll write DAC is equal to DCA. So now we have got first equation, that is DAC is equal to DCA. So now I will rewrite this particular second equation as well. So here you can see in the third equation, that is the given, whatever they have given in the question, that is DAC is equal to CAB. And in second equation, we have DAC is equal to ACB. So in the place of DAC, I'll substitute CAB. So in the place of DAC, I'll substitute CAB and I'll make this CAB is equal to ACB. So I'm just writing this second equation where I am substituting DAC with this particular CAB. So CAB will be equal to ACB. So now from first equation we have rewritten as DAC is equal to DCA, and second equation we have written as CAB is equal to ACB. So that means here in this particular diagram, all these four angles are getting equal to each other. So therefore, DAC is equal to DCA is equal to CAB is equal to ACB. So here all these four angles are getting equal to each other. So since all four angles are getting equal to each other, here this particular angle, that is DCA, this particular DCA is equal to ACB. So therefore DCA angle is also equal to ACB angle. Why? Because all these four angles are getting equal to each other. Because if you look at this particular equation, so in the first equation we have written CAB is equal to DCA, and we have written in the second equation DAC is equal to ACB, and in the given they have already given that DAC is equal to CAB. So based on that, we have written second equation as CAB is equal to ACB and DAC is equal to DCA. And this DCA is also equal to CAB. So if DCA is equal to CAB, then DCA is also equal to ACB and DCA is also equal to DAC. So that means all these four angles are getting equal to each other. So if all these four angles are getting to equal to each other, means here DCA is equal to ACB. So that means here, therefore, AC is bisecting angle C. So therefore AC is bisecting angle C. This is because here we have got DCA is equal to ACB. Here DCA is equal to ACB. So that's why AC is bisecting angle C. Now we will look into the second question in the same third question. In second question, they have asked that you need to prove that ABCD is a rhombus. You have to prove that ABCD is a rhombus. In order to prove that ABCD is a rhombus, you have to prove all the sides are equal to each other. Because a rhombus, whatever the angles might be, whatever the interior angles might be, but all the sides will be equal. In a square, all the sides and all the interior angles will be equal. But in rhombus, we don't have any restriction of all the interior angles becoming equal to each other. We just need to prove that all the sides of a particular quadrilateral, or here they have given parallelogram ABCD. So if we prove all the sides of this parallelogram are equal to each other, then that becomes rhombus. So ABCD is a rhombus, we need to prove here. So in order to prove that, we need to prove AD is equal to DC is equal to AB, which is equal to BC. So here, since ABCD is a parallelogram, so since ABCD is a parallelogram, here in parallelogram opposite sides will always be equal to each other. So that means AB will be equal to DC, and here AD will be equal to BC. This is according to theorem 8.2. So if you don't know what is theorem 8.2, you can refer my previous video where we have discussed that opposite sides in a parallelogram are equal to each other. So now AB is equal to DC and AD is also equal to BC. So now opposite sides are equal. We need to prove all the sides are equal to each other. So in order to prove that, we need to prove AB is equal to AD, or we need to prove DC is equal to BC. So either of the side we need to prove they are equal to each other. Either DC and BC you can prove, or you can prove AB and AD. Or you can prove AB and BC, or you can take DC and AD. anything, any two sides you can take in both of the equation, that is in AB is equal to DC and in AD is equal to BC. So in those two equation, either of the side you can take from the first one and you can prove it is equal to either of the one in the second one. Here the diagram which they have given is like this. So we have a parallelogram A, B, C, D, and they have given a diagonal AC. So, and we already know that this particular angle and this particular angle are equal to each other, and this particular angle and this particular angle are equal to each other. Now we will just consider this particular triangle. So in triangle ABC, now we will consider in triangle ABC, angle CAB is equal to angle BCA, because this we have already proved that all these four angles are equal to each other. We have proved all these four angles are equal to each other. So this angle will be equal to this angle. So CAB is equal to BCA. This we have proved in the first question. This we have proved in the first question. So if you have not proved in exam, if they just ask the second part of the question, then you have to do the first part in order to get this CAB is equal to BCA. And then you can come to this second question. So we have proved in the first question that this particular angle is equal to this particular angle. That is also equal to this particular angle and this particular angle as well. So now we just take CAB and BCA because we are just considering ABC triangle. So CAB is equal to BCA. This angle is equal to this particular angle. And in the previous chapter, in the triangles chapter, we had discussed that if the angles, two angles in a triangle are getting equal to each other, then the opposite sides of those two angles will also be equal to each other. That is, opposite side of this particular angle, so opposite sides of the side of this particular angle is this, and opposite side of this particular angle is this. So that means AB is equal to BC. So therefore AB is equal to BC. In bracket you can write CAB angle is equal to BCA angle, or you can write property of isosceles triangle. So property of isosceles triangle. This also you can write in the bracket. So this is the reason how this particular AB is getting equal to BC. And we already know here AB is equal to DC. So we know that AB is equal to DC and AD is equal to BC. This is according to theorem 8.2. This is according to theorem 8.2 because ABCD is a parallelogram. Now we have proved that this particular AB is equal to BC. So this is, we have proved, just now we have proved this. So now here you can see AB is also equal to DC and AB is also equal to BC. So that means therefore BC is equal to DC, since AB is equal to DC and AB is also equal to BC. Since AB is equal to DC and AB is equal to BC, BC is equal to DC, and we know that BC is equal to AD. So AD will be equal to BC, will be equal to DC, and we know this is equal to AB. So that means here AD is equal to BC, which is equal to DC, which is equal to AB. That means all the sides in this particular quadrilateral are getting equal to each other. Therefore, ABCD is a rhombus. Why ABCD is a rhombus? Because we have proved that all the sides in this particular quadrilateral or in this particular parallelogram ABCD are equal to each other. So that's why ABCD is a rhombus. Next, we'll look into the fourth question. So fourth question is similar to third question, but here you need, here instead of giving parallelogram, they have given rectangle, and now we have to prove that it is a square. That's it. So now we will draw this particular rectangle, and they have given AC as a diagonal. Here we will name this particular rectangle as ABCD. And here they have given AC is a diagonal which is bisecting angle A, and also it is bisecting angle C. That is, this particular angle is equal to this particular angle, and this particular angle is also equal to this particular angle. So here what they have given is DCA. So DCA is equal to ACB. So that is this particular angle and this particular angle are equal to each other, and DAC is equal to CAB. That is this particular angle DAC is equal to CAB. Now here, based on this data, you have to prove that ABCD is a square. So now here we need to prove that this particular angle is also equal to this particular angle. So here we have DCA is equal to ACB and DAC is equal to CAB. Here, since this is a rectangle, in rectangle is also a parallelogram. We know that rectangle is also a parallelogram. So since ABCD is a rectangle, since ABCD is a rectangle, here opposite sides will be parallel to each other, because the rectangle is also a parallelogram. So DC is parallel to AB, and here AD is also parallel to BC. So DC is parallel to AB and AD is parallel to BC. So therefore here DCA, that is this particular angle DCA, will be equal to this particular angle CAB. DCA is equal to CAB, and because AD is parallel to BC, because AD is parallel to BC, this particular angle DAC, so this particular angle DAC is equal to this particular angle ACB. So now DCA is equal to CAB and DAC is equal to ACB, and we also know that DCA is equal to ACB, and we also know that DAC is equal to CAB. This is already given. So these two are already given, which I have written here. So these two are given and these two we have proved because opposite sides are parallel to each other. So here DCA is equal to CAB and DCA is also equal to ACB. DAC is also equal to ACB and DAC is also equal to CAB. So that means here, how we did in the previous question, here also all four angles are getting equal to each other. That is DCA is equal to, so you can take this, DCA is equal to CAB is equal to ACB, DCA is equal to CAB, which is equal to ACB, which is equal to DAC. So all four angles are getting equal to each other. So now we'll consider this particular triangle ABC. So consider triangle ABC. So consider triangle ABC. So in triangle ABC, we know that these two angles are equal to each other. Just now we have proved all four angles are equal to each other. So that means these two angles will be equal to each other. That is CAB and ACB. So CAB is equal to ACB. This we have proved. So this we have proved. So therefore here AB will be equal to BC. This is because CAB is equal to ACB, and you can also write triangle and you can also write isosceles triangle, or you can write property of isosceles triangle. So according to property of isosceles triangle, because CAB is equal to ACB, AB is equal to BC, and in rectangle opposite sides are equal to each other. So in rectangle opposite sides are equal. So opposite sides are equal in a rectangle. So that means here AB is already equal to DC and AD is already equal to BC. So AB is equal to DC and AD is equal to BC. So since AB is equal to DC and AD is equal to BC, and just now we have proved that AB is equal to BC. So we have proved AB is equal to BC. So there here AB is equal to BC. This we have already proved. So since AB is equal to BC, AB is also equal to DC. So that means AB will be equal to BC will be equal to DC, and we also know that this particular BC is equal to AD. So this is also equal to AD. So that means AB is equal to, so therefore AB is equal to BC is equal to DC is equal to AD. So in rectangle ABCD, so therefore in rectangle ABCD, all sides are equal. So all sides are equal. Hence ABCD is a square. So at last we have proved that ABCD is a square. Similarly, you have to prove the second question, diagonal BD bisects B as well as D. So that means here, if you take the same diagram A, B, C, D. So now if you draw a diagonal BD like this, here also you have to prove that this particular angle and this particular angle are equal to each other, and this particular angle and this particular angle are equal to each other. So in order to prove that, you can take this particular diagonal also AC. So now we are solving the second question in the same fourth question. In the second question, you need to prove that this particular D is bisected by this diagonal BD. That means you have to prove this particular angle and this particular angle are equal to each other, and you have to prove this angle and this angle are also equal to each other. That is, BD also bisects B and D both. So now in this particular diagram here, this diagram we have already proved that this is a square. So here we have proved. So in exam you cannot write this, because in exam if they only ask this particular second question, you have to prove the first question. That is, you have to prove ABCD is a square, and then you have to solve this. So here we have already proved that ABCD is a square, so that's why I am writing this particular statement. So here we have proved ABCD as a square. So we know that ABCD is a square. So now this intersection point of two diagonals, we'll call this as O. Now we'll consider this triangle and this triangle. So now consider triangle AOD and triangle DOC. So in these two triangles, we know that we have already proved that AD is equal to DC, because ABCD is a square. So here we have AD. So that means here we are considering these two triangles. So here we are considering these two triangles. So this is point O, this is A, this is C, and this is D. So here AD is equal to DC, and this particular A angle is also equal to C angle, and this side we need to prove that they are equal to each other. So then according to SAS postulate, we can say that this particular two triangles are congruent with each other. So now AD is equal to DC. So AD is equal to DC. This is because ABCD is a square. So ABCD is a square. So AD is equal to DC. Now we'll consider this particular angle and this particular angle. This also we have proved that this angle, and we have proved this angle and this angle. All four angles are equal to each other. We have proved that in the previous case. So here angle DAO is equal to angle DCO. This we have proved. How we have proved this? We have proved that DAC is equal to DCA. Now we are taking that O, that's it. On this particular AC, we have considered this point O. So that's why we are just considering that particular point. Instead of considering A, we are considering O, and instead of considering C, we are considering O. So in the place of DAC, I have written DAO. In the place of DCA, I have written DCO. So DAO is equal to DCO. This we have proved in the previous case. Now we know that this particular side AO and this particular side OC is equal to each other, because in square diagonals bisect each other. So since diagonals bisect each other, so since here in the bracket you can write diagonals bisect each other. Why diagonals bisect each other? Because ABCD is a square. That also you can write. Diagonals bisect each other since ABCD is a square. So that means here AO is equal to OC. So now according to SAS axiom, so therefore according to SAS axiom, so according to SAS axiom, here triangle AOD is congruent with triangle DOC. So therefore, if these two triangles are congruent, then this angle will be equal to this angle. That is, ADO will be equal to ODC. ADO is equal to ODC. That is because AOD and DOC triangles are congruent with each other. Now one part of the question we have proved, that is this particular. So here you can write, therefore BD bisects D. So therefore BD diagonal bisects angle D. So one part we have proved. We have to also prove that this particular diagonal also bisects angle B. So now in this particular diagram ABCD, so in this particular diagram ABCD, we have two diagonals, one is AC and one is DB or BD. So this center point we have considered as O. Now we have considered these two triangles and we proved that they are congruent with each other, and we got these two angles are equal to each other. So that means D is bisected by BD. Now we can consider these two triangles in order to prove that this particular triangle, so this particular angle will be equal to this particular angle. So here we consider these two triangles. So this is O, this is A, this is B, this is C. So now here you can consider these two triangles, that is AOB and BOC. Here we know that this particular side will be equal to this side because diagonals bisect each other in this particular square. So since ABCD is square, AO is equal to OC. And this particular angle is equal to this particular angle, that we have already proved, because CAB is equal to ACB. Or in this particular case, you can take OCB is equal to OAB. And this side are equal to each other because ABCD is a square. So AB will be equal to BC. So here also, according to SAS axiom, these two triangles will be congruent with each other. Since these two triangles are congruent with each other, this angle and this angle will be equal to each other. Since this angle and this angle are equal to each other, this particular BD bisects angle B. So how I did for the first part in this second question, similarly you can try on your own by considering these two triangles. I have considered upper two triangles and I have proved this particular angle and this particular angle are equal to each other. So BD is bisecting D. Similarly, you can consider these two triangles and you can prove this angle and this angle are equal by proving these two triangles are congruent with each other, and thereby this particular BD is also bisecting angle B. You can do this on your own. So this is all there in this particular video. The remaining questions in this particular exercise I will be teaching in my next video. Until then, if you want to learn more physics, chemistry and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.